Hey, welcome back to the Crow's Nest Railroad. We're back at Bob's workshop today doing some more work on the Chloe, and you're going to see it cranking over sort of this week, so stay tuned. All right, Bob, this is the D-valve assembly that we looked at last week, and we couldn't get it working. What was the magic that you did to it this week that we got this thing working?
In this case, Stan, was that this stainless steel keeper in here, which lifts out, should not have any bind at any point of this movement back and forth. So what was happening last week was that this was sticking to that keeper, and it was lifting this D-valve off the surface of the cylinder. If you look carefully, you'll see the D-valve, when I lift up here, stays in place. When I lift the other way, just a little bit of lift, and that's where the problem is.
Little
we come
sticky
back
on
here,
that side.
we lift this side, no problem. This side, better. So right here, somehow we've got just a little bit of possible lift still remaining on this keeper. So I take the keeper out, we end up with it getting sanded with emery cloth on this surface plate, and that gives us the conditions we need to dimensionally shrink that down so it clears this groove a little smoother.
Can you flip it over so we can see the ports on the... Okay, see that chamber on the bottom? So that should alternately connect the exhaust port in the middle and the two injection ports.
Yes.
Okay.
So this is just sized right so that any time it's in its position of movement, the exhaust chamber is open. But when it moves off to one side, it exposes the inlet to the front of the piston, and moving forward, it exposes the inlet to the back of the piston. But at the time that it moves forward to show the back piston inlet, it's allowing the front inlet port to connect through this cavity to the exhaust port, which then exits the steam through the cylinder. As this works back and forth, alternately the front inlet port and the rear inlet port are exposed to the center cavity, allowing the steam to exit through the center exhaust port.
Now this has to be held down apparently very tightly to the bottom of that steam chest, right? And there's nothing right now other than its own weight that's holding it down.
That's correct. So when this whole assembly comes together and gets full steam pressure through the steam port, which is through at the side of this opening on the cylinder itself, it pressurizes this whole zone, pushing down on this D block, as well as trying to slip it underneath the front lip.
Yep.
So it's that pressure pushing down, and in this case, about 170 pounds pressure pushing down on this block at 100 psi steam pressure, which means there's 170 pounds pressure loading this zone here, which is where the wear occurs on top of the cylinder casting itself. So that whole thing slides back and forth 5/8 of an inch fairly rapidly, as this little engine only has 5-inch diameter wheels.
So before we put this back together again, I thought I'd give us a shot of these ports, and Bob can explain. The steam comes in over here in the corner.
And Stan's got it exactly right. There's a small hole here in the corner, and that goes into the incoming steam line, which drops through the saddle. The saddle here is hollow, and it makes a 90-degree bend and comes into a port in the side of this casting. Comes up through a hole and fills this entire steam chest area. This is called outside admission once again because the steam is entering in the cylinders from the outside of the D block valve. So this is into the cylinder front, into the cylinder back, and this is the exhaust port going out through the saddle itself. So we're going to go ahead and put this assembly back together on the steam chest sides. We'll put the D valve in there, we'll put the keeper and the valve stem all in one assembly, and that's what that keeper, that bronze block, slides over back and forth and exposes either of these two inlet slots or the central exhaust slot.
So what we heard was the engineer side, the starboard side of this locomotive, pulling and pushing without any assistance from this side. So it has a loping sound to it because only half is really doing the work. The trick is we've got to get this side starting to pull its own weight here on the fireman side, the port side.
And that's the trick, is getting this timed with the pair of eccentrics at the back as well as the length of the valve stem. So there's three variables going on that we try and find the sweet spot on that makes it work as good as the other side.
Anyway, when we set those eccentrics up so that the timing of the steam makes sense for these drivers, so it's putting air pressure or steam pressure, we're using air right now, both behind and in front of the piston, it looks great. However, once we go back to neutral, this D-valve should not be allowing steam pressure on either side of the piston. And currently, that's our struggle. We can't get both of those variables timed in at the same time. We get either or right now. So there's a parameter in here that needs to be adjusted, and that's what we're struggling with. I'm sort of a distraction in Bob's shop here. So I'm going to let him continue to cogitate on this, but I will, of course, give you updates as to what's happening on this really cool Chloe here. So I'm going to wrap it up for this week. Thanks so much for joining us here on the Crow's Nest Railroad, and thanks, Bob, so much for allowing us to intrude in your shop and take a look at what it's like really to take a problem that has an origin somewhere that you didn't see, and then you're trying to figure out where the problem is and how to fix it right. We've got this side working. Now we got to get the fireman's side, the port side working as well. So I'll see you guys right here next time.